Hello, my distinctive students in Anbar, especially, and in Iraq generally. Today, I will explain chapter 6, entitled The Reflection of the Light. Of the light. The reflection. A ray of light, the incident ray, travels in a medium. When it encounters a boundary with a second medium, part of the incident ray is reflected back into the first medium. This means it is directed backward into the first medium. Okay, you can see this figure. This incident ray and this is the reflected ray. Okay, we have two types of the reflection. First one, specular reflection. Specular reflection is reflection from a smooth surface. This is smooth surface. Okay, the reflected rays, reflected rays are parallel with each other. Okay, and one incident ray give one reflected ray. Okay, one incident. This example or this mean this type of called specular reflection. Okay. This type of the okay, and all reflection in this text is assumed to be specular. Reflection. Second one, diffuse reflection. Diffuse reflection from a rough surface. This object with a rough surface. Okay. The reflected rays travel in difference of direction. Okay. I mean, one incident light or ray give number of reflected rays. Okay. In specular, one incident ray give one reflected ray. But in diffuse reflection, one incident ray give numbers of the reflected rays. Okay, and not parallel to each other. Okay, reflected in different direction. Okay, these properties of diffuse reflection, and you can give the difference between the two types. Okay, this diffuse reflection use it in light of car because make the road easy to see at night. Okay, the normal is a line. And this normal is a line perpendicular to the surface or vertical to the surface. It is at the point where the incident ray strikes the surface. Okay, when the incident ray strikes the surface, the incident ray makes the angle of theta 1 with normal. So this incident ray and this is incidence angle. The reflected rays makes the angle of theta 1 prime also with normal. So this reflected ray and this reflected angle. Okay. Laws of the reflection. Laws of the reflection. You can see or not. Okay. Sorry for that. Incident. First one. Incident ray, reflected ray, and normal all lie on the same plane. This first law. Second one, the angle of the reflection equal to the angle of incidence. Okay, the second one. Okay, example for second law. Suppose the incident angle is 30 degree. Okay, what the angle of reflected or reflection? Okay, according to the laws of second law of the reflection, theta 1 equal theta 2, or the angle of reflection equal to the angle of incident. For that, the reflected angle will be theta also. Okay. Again, if the incident angle equal 30 degree, what the reflected angle? What is the reflected angle? The solve according to laws of the reflection. The second law, the angle of reflection equal to the angle of incidence. For that, the reflected angle equal 30 also. Okay. Now I give you a question. If the incident angle equal 45 degree, what is the angle between the incident ray and reflected ray? You can write the answer in comments. Okay. The refraction of the light. When a ray of the light traveling in a transparent medium encounters a boundary leading into a second medium, part of the ray is reflected and part of the ray enters the second medium. The ray that enters the second medium is bent at the boundary. This bending of the ray is called refraction. Okay, you can see this incident ray, this refracted ray, okay, and this refracted ray. Okay, you can see the reflected ray and incident ray in same medium, but refracted ray in another medium, because it's enter the medium. Okay, incident ray and refracted ray incident ray, refracted ray, and normal line on the lie on the same plane. Okay. Second one, the ratio of sine theta 1 to sine theta 2 is constant. This leads to the angle of reflection theta 2 depend on the properties of the medium. Okay, here refraction details. Okay, air, I have two mediums, air and glass. Okay, the light speed of the light in air bigger than in glass, I mean faster than in glass. Okay, incident ray, or in air the incident angle will be bigger than refracted angle. Okay, why? Because incident ray in air and refracted ray in glass, okay, according to the speed of the speed the light in air faster than in glass. For that will result the incident angle bigger than refracted angle, or you can see refracted angle smaller than incidence angle. Okay, now the incident ray in glass. Okay, in glass, you know the speed of the light smaller than the speed in air. For that will result the refracted angle bigger than the incident angle. Or you can say the incident angle smaller than reflected angle. Okay, now talk about index of the refraction. N. Define the velocity of light in the optically denser medium, C over N. Index of refraction, N, equal C over V. C is speed of the light in vacuum, and V, speed of the light in medium. Okay, and this difference according to medium. Okay, this table for index of the reflection for some substance. Okay, Snell Law. Wave of light or light ray passes from a low N to high N. It bends toward the normal. Okay, and wave pass if light ray, or a light ray passes from high N to low N, it bends away from the normal. You can here. Okay. This N smaller than glass. For that reflected ray close to normal. Okay. When the light passes from high N to low N, the reflected ray away from normal. Okay, if N is the same for both media, the wave does not bend. Okay. The equation of Snell law. Okay, you can see this incident ray here incident ray. Okay, this incident angle and reflected ray on this refracted angle. So you can prove the Snell law and get this result equation for Snell's law n 1 times sine theta 1 equal n2 sine theta 2, where n1 equal is the index of reflection for first medium, theta 1 incident angle. N2 is index of reflection for second medium, and theta 2 is refracted angle. Okay, will be now we'll take examples. Okay, example 1, a light wave passes from air to water if the angle of incident is 60 and the angle of refraction is 40.5 degree. What is the index of refraction? Okay, we will solve according to Snell's law. Write equation, first one, n1 sine theta 1 equal n2 sine theta 2. n1, the first medium is air. n for air equal 1, and incident theta is 60. Okay, refraction angle 40.5. Okay, right, but 1 for n1 sine 60 equal n sine 40.5. Give answer for volume of sine 60 equal 0.866 equal n, and value of sine 40.5 is 0.665. So n equal 0.866 over 0.65, n equal 1.33. Okay, very easy. Second example, a light beam passes from water n equal 1.33, this first medium, into diamond, this diamond second medium, n for diamond equal 2.42. The beam mean ray is incident upon the interface at an angle 56 degree from the normal. What is the refracted angle of the light? Okay, this diagram also according to equation of Snell, n1 times sine n theta 1 equal n2 sine theta 2. Okay, you can see the answer same way for first example. Okay, but n1 equal 1.30 sine 55 volume times by 1.33 equal 1.1 and equal 42 sine theta 2. Sine theta 2 equal 0.455 by divided 1.1 over 2.42. Okay, sine theta 2 equal 0.455. You can get theta 2 where theta 2 equal sine inverse 0.455. Okay, so theta 2 equal 27.1. Okay, here were the ends of the lesson. Before the end, remember, you can see everything around you by reflection of the light about them. Okay, thank you and good luck.